Hi guys, in today's video we will try to uh, explore Windows to view transformation in computer graphics. So first of all, I will like to say you something about how to use this lecture note and this video. First, what you have to do, you have to go through this lecture note which is shared with you. Then after skimming through this, next you have to come to this lecture video, and after watching the video, then again go back to the note and read it carefully in between the lines. If you have not read it for the first time, then just pause the video and go to the lecture note and read it carefully, then come back. So the key terms in this topic are window and viewport. First, let we look into the bookish definition for window. In computer graphics, a window is a graphical controller unit. It consists of a visual area containing some of the graphical user interface of the program it belongs to and is framed by a window decoration. In simple terms, a window defines a rectangular area in world coordinate. Now, this was the bookish definition. How you can understand the concept of window? If we bring the real world analogy, the task will be much simpler. Window in computer graphics is much similar to the windows which we have in our houses. If you carefully observe, outside of our window there is an infinite world which is not visible while you are inside your room. Only the portion of the outside world which you can see through the window is visible. But it doesn't mean that the world does not exist. The same concept is applicable here. If you come to this diagram, you can see that you have a larger outside world which is defined in terms of a world coordinate system. This is the x-axis for world coordinate system, and this is the y-axis of world coordinate system. Now say you fit one flipping window onto this world, and now this window is something like the windows of your house. What will happen? You will only be able to see the area of the outside world which is visible through this window, and this portion of the outside world is hidden now. So you can say that in our human visual system, outside portion of the window is now flipped. So If you think it in another way, if you have a point x, y here, now to define this point xy, you have another added coordinate system, which is the world coordinate system. So until now, this point xy has two definitions. One in terms of world coordinate, another in terms of this window coordinate system. Now, then, what is viewport? Let me go back to the bookish definition for viewport. It says an area on a display device to which a window is mapped is called a viewport. Just give it a thought. You have clipped a portion of the world using your window. Now, what you are doing, you are displaying the contents which are visible through the window on some display device. And area on the display device to which you have mapped the contents of the window is called your viewport. A viewport is a polygon viewing region in computer graphics. The viewport is an area expressed in rendering device-specific coordinates, as for example, pixel for screen coordinates, in which the objects of interest are going to be rendered. You can understand the concept of viewport with this simple example. Let me take the example of an web browser. So this is a web browser, and when you open a web page, just ask yourself a question: is the entire web page visible to you? No. The entire web page exists at a certain point of time, but only the portion of the web page which is fitted onto your computer screen for the particular time is visible to you. So this is your viewport, and entire web page is your world. Now let me go back to our content. Now, to transform the contents of the clipping window to viewport, what you did, you designed a display system which has its own coordinate system definition. In this example, it is defined with 4 coordinates: xv-min, xv-max, yv-min, yv-max. So, and then what you did, you rendered the contents of the clipping window, what is visible through this window, onto your viewport. Now let me do a little coordinate geometry. So try to figure out what are the coordinates of the 4 corners of your clipping window and the 4 corners of your viewport. It will be the left side coordinate is This will be xv min yv max. The left upper corner. Now try to find out what will be the coordinate for the right upper corner of the viewport. It will be xv max yv max. Again, try to find out the coordinate for the lower right corner of the viewport. It will be xv max yv min, and the coordinate for the lower left corner is xv min yv min. So these were the definition for the coordinates of your viewport corner, which is rectangular. Now try to find out the coordinates of the corners of your rectangular clipping window. You can see the coordinates are defined here. Let me write them as we did for viewport. The upper left corner is what is happening here? Okay. The upper left corner will have coordinate xw min yw min. The upper right corner will have xw max, comma yw max as its coordinate. The coordinate for the lower right corner is going to be xw max and yw min, and lastly the coordinate for the lower left corner is going to be xw min yw min. So now we have been able to define our rectangular clipping window and our rectangular viewport in geometrical terms. Now the point you have to notice that you have to map each and every point in your rectangular clipping window to the pixels of rectangular viewport. This is your task in a nutshell. So again, we have figured out that rectangular window is defined in terms of four values, if you can recall, and they were xw min, xw max, yw min, yw max. Again, the viewport is defined in terms of four tuples, and they were xv min, xv max, yv min, yv max, right? So now your task will be to establish the mathematical relationship between the coordinates of rectangular clipping window and the coordinates of rectangular viewport. So we have had some general terms which are also defined in the note. Just have a look at those uh, definitions. First one is uh, world coordinate. It is the Cartesian coordinate with respect to which we define the diagram like xw min, xw max, and so on. Then you have the device coordinate, or the coordinate of the viewport, as we have defined, and it is defined in terms of xv min, xv max, yv min, and so on. Then we have another term, window. It is the area on world coordinate selected for display. Then you have the definition of viewport. It is the area on device coordinate where graphics is to be displayed. Next, you have to establish the relation, a mathematical relation between window and viewport. To do this, let's say you have a point xw, yw on your rectangular window, which in this diagram we refer to as x, y. Next, you have to find out the corresponding point on the viewport. That means the point on the viewport where your this world coordinate point is going to be mapped. That means you have to find out the corresponding point on the viewport which will represent this point xy. To do this, you have to uh, normalize the point on the window. How this normalization is performed? The world coordinate point, that means the point in question, minus xw min over xw max minus xw min. Then do the same normalization for the y value also. It looks like yw, that means the y coordinate for the world point minus yw min over yw max minus yw min. So next, the corresponding normalized point for this in your viewport is going to be xv. That means the corresponding point on the viewport which has x coordinate xv minus xv min. That means minimum x value of the coordinates of the corners of the viewport over xv max minus xv min minus yv minus yv min over yv max minus yv min. Now, here comes the concept of similarity. For two points to be similar onto different systems, the ratio must be similar. Actually, to calculate xv and yv, we are going to use that property. What I mean to say, this is your ratio in world coordinate system and this is your ratio in viewport coordinate system or display coordinate system, and this is your ratio in the world coordinate system for the similar point. So for the similarity property to hold, these two ratios must be equal, right? Once this equation is in place, if you solve this to find the value of xv, xv will look like this. xv equals to xv min plus xw minus xw min whole multiplied with sx, and the same calculation for y coordinate will look like this. yv equals to yv min plus yw minus yw min multiplied with sy. So what are sx and sy here? Sx is the ratio of xv max minus xv min. That means ratio in between the span of x coordinate of your viewport and the span of x coordinate of the world clipping window. Similarly, sy equals to span of y coordinate, that means yv max minus yv min, span of y coordinate yv max minus yv min. This is your span for along the y-axis onto viewport, yv max minus yv min, and this is the span along y-axis into your rectangular clipping window, which is yw max minus yw min, and sy is the ratio between those two spans. So some step jumps was there in these calculations. Your task will be to complete the steps which were in between these two equations, right? Now here we have an eraser tool. Where is eraser tool? Eraser. Let me erase this. Here we have an example for this calculation. Just look into the problem. Let's assume for window xw min equals to 20 and xw max equals to 80, yw min equals to 40, yw max equals to 80, and for viewport these are your viewport definitions. Now a point xw yw 3080 on the window. On the window the coordinate of a point is 3080. You have to calculate the point on the viewport. To do this, let me do one thing. Just copy the problem. Copy. And paste the problem on our board. Just what's going on? Yes. First, it says that window is defined by these four values. So if this is your clipping window, if this is your clipping window, this x min y min coordinate, x min y max coordinate is, that means the coordinate for the upper left corner is 20, 80. The coordinate for the upper right corner is 80, 80. Right? The coordinate for the lower right corner is 80, 40, and the coordinate for the lower left corner is 20, 40. Similarly, try to define the coordinates for the viewport. This is our viewport and this is our window coordinate system. Next, the point says that there is a point whose coordinate is 30, 80 into the world coordinate system. That means the point is somewhere here. $30, $80. Now you have to find the corresponding point onto the viewport, which will be mapped with respect to this. So this is your task. How this has been done? First, Sx and Sy has been calculated. The formula for Sx has been established as Sx equals to xv max minus xv min over xw max minus xw min. You calculate the Sx ratio. Similarly, you calculate the Sy ratio for the y values. Now, by following these two equations, you can compute the value of xv and yv, that is the corresponding point onto the viewport. This you try to do it yourself and match with the result which is given in this example. In this way, you will be able to learn how to transform a point from window to viewport, right? So, thank you.